Hello and welcome to Beware of the Dark Side, Oracle for the SQL Server DBA. My name is David Postlethwaite. I'm a DBA for a large financial services company on the south coast of England. I've been working as a DBA for the last 10 years and I currently manage both SQL and Oracle instances. Previous to that, I was a developer using .NET, SQL, Access, FoxPro and Oracle, and way back in time I was a Windows and a NetWare administrator. I'm an occasional contributor to the blog on gethanellis.com, and if you wish to contact me, my details are on the screen. Now, when I started out as a DBA, I was dedicated to SQL Server, but eventually I had to start supporting Oracle databases. And moving from a Microsoft environment with SQL Server to Linux and Oracle was very hard and frustrating. The terminology that I got used to was suddenly turned on its head, and sometimes when I thought I understood it all, I would find myself becoming totally confused and having to start all over again. But now I have gained enough experience, I believe, to be able to share my knowledge with you so that hopefully you won't have to go through the pain and frustration that I've had to endure. This talk is really aimed at DBAs, looking at the difference and similarities in the infrastructure between Oracle and SQL Server. I'm not going to go too deeply into the differences between T-SQL and PL/SQL, but there will still be useful stuff for developers as well as DBAs, so stick with me. My aim is to give you an overview of the Oracle database system so that you can converse with Oracle DBAs on equal terms. So here goes. Talking about Oracle and SQL Server brings out the best and the worst in the IT community. Try searching on the internet for I hate Oracle and you will find loads of articles, even whole websites dedicated to putting down Oracle, usually from people who are used to using Windows. There's even an Oracle haters club that will sell you a t-shirt and a coffee mug. Conversely, you can find plenty of articles by Oracle DBAs trashing SQL Server, usually about its limited configuration options. You probably have an opinion of Oracle. They both have their plus points and their drawbacks, and your opinion will be biased by which product you used first. Despite its reputation for being difficult to install and manage, Oracle still is the world's most popular database system. So why is Oracle so popular? Well, it's been around much longer than SQL Server. It was first released in 1979 for the VAX, when I was still at school. It's acknowledged as being the first commercially available relational database system, so it captured the market. By 1985 it had a client-server version, allowing it to gain massive market share, and at this point SQL Server was just being launched on OS 2 as a desktop database. By 1992 it had a 64-bit version, allowing it to manage enterprise-sized database. At this point SQL was still a desktop 16-bit database. In 2001 it introduced Oracle RAC, or Real Application Clusters. RAC allows several instances of Oracle to run as an active cluster, all talking to the same set of database files, which gives it a huge lead in high availability and scalability. SQL Server still doesn't really have anything that can do that. I wrote this presentation way back in 2014 when the idea of SQL on Linux was still a standard joke and the cloud was in its infancy. Since then, Microsoft has added SQL 2014, SQL 2016, 2017, and of course SQL Server on Linux. Now Linux is not so alien to SQL people, and containers and the cloud are mainstream. Interestingly, whereas SQL has had 2 or 3 new releases with lots of new features, Oracle has still not had a real new release since 2013. It's now rebadged its current version as 18C, but really it's still version 12C. Oracle has realized it needs to look new and fresh, so it's releasing annual updates, and the name has simply been changed to reflect the year the update was released. As I've already said, Oracle runs on many platforms. This is a complete list of all the platforms for current version 12C, so you can see we can run it on Windows and Linux, Solaris, and various other things. Z Linux, which is a Linux operating system for the IBM mainframe. Oracle obviously has its own cloud offering, and you can run Oracle on Microsoft Azure as well as AWS. But this multi-platform ability has given Oracle an advantage over SQL Server, which has until recently only worked on Windows. Has SQL Server on Linux actually changed anything? I'm not sure, but the fact that you can run Oracle on so many different systems compared to SQL Server does give it an advantage. If you thought Oracle was just a database, you'd be wrong. Just like Microsoft is more than just Windows, Oracle, the company, produces more than just Oracle, the database. It has development tools like Oracle Forms, Oracle Apex, Oracle Edge, Java. There are numerous middleware products such as PeopleSoft, e-Business Suite, which is a suite of enterprise business applications, Oracle Financials, which are used throughout the financial industry, JD Edwards, which is an enterprise resource planning tool. You've got Web Center, which is an equivalent to SharePoint. You have all the BI tools, alternatives to analysis services, integration and reporting services. We have WebLogic, which is a really powerful application server. It owns operating systems such as Solaris and Linux. Oracle can provide its own hardware, such as Sun Sparks, Sun 86, Oracle Superclusters, Blade servers, and Exadata. And naturally, Oracle has its own cloud offering called Oracle Cloud, which also offers all Oracle features, but only Oracle features in a public cloud. So you can see that Oracle can offer a complete solution for your database requirements from the ground up. Now, just like SQL Server, there are several different editions of Oracle. And with Oracle 12c, there are 4 choices. Oracle Express, which is a free entry-level system limited to just 1 CPU and small databases, free to develop, deploy and distribute, with a simplified administration program. We've got 2 standard editions, commercial versions offering standard database features, one with slightly less power available to it than the other. But they both support Oracle RAC, the real application clustering. Oracle Enterprise includes all the features you would expect in an enterprise system with unlimited memory and CPU. You can download all versions from oracle.com for free for testing and learning. Now, one thing that Oracle does different to Microsoft is cost options. When you buy SQL Server Enterprise Edition, all the extra features that come with Enterprise are available to you out of the box at no extra cost. Not so with Oracle Enterprise. To use some of the enterprise features such as compression, partitioning, spatial data types, replication, in-memory databases, you have to purchase an extra license, and this is where Oracle can become very, very expensive. You thought you bought the Enterprise Edition, you had all these features, but you only have the right to use them once you've purchased the extra license with it. Now, just like Microsoft, you can gain certifications in Oracle systems. It has a similar structure to Microsoft, exams with multiple choice questions. The basic level is Oracle Certified Associate, or OCA. It requires that you pass 2 exams. The first exam, SQL Fundamentals, you can take online at home, so you could look up the answers on the internet or check the answers against your own database while you're doing it. And the second exam you take at a test center. The second level is OCP, or Oracle Certified Professional. This requires that you attend an Oracle Certified training course, not just any Oracle course, but an approved course for this certification with an approved instructor, and then complete another exam at a test center. There was a certification called Oracle Certified Master, but this has been dropped for 12c. Interestingly, Oracle are still offering a 1 exam upgrade for OCPs from any version of Oracle after version 7, which was released in 1997, to the current version. I wonder how many people certified in SQL 2000 or SQL 7 would like the chance to move straight to a SQL 2017 certification. Now, that's some background to Oracle. Let's move on to some of the more technical aspects. Oracle and SQL Server treat the definition of instance, database and schema in completely different ways. If you can grasp this, then you're halfway to understanding the Oracle database. First of all, let's remind ourselves what a SQL Server is made of. In SQL Server, an instance consists of processes, the SQL Server service, SQL Agent service, and the allocated memory that SQL Server takes. SQL Server has a set of system databases. As a minimum, SQL Server must have a master database, model, MSDB, and tempDB database, each with their own set of physical files. To function, the SQL instance must have all of these components. It cannot start or work properly if any of them are missing. You will normally have a set of user databases. Again, each user database will have its own set of files. So in SQL Server, creating a database implies adding a user database with its own set of unique files to the already existing system databases. Now finally, with SQL Server 2005, Microsoft introduced the idea of a schema. Now in SQL Server, a schema is a way of grouping objects such as tables and views. The default schema is called DBO, and that's where most people place their objects. Schemas do allow some security over who can see and use them, but in my experience, the schema is generally used a way of just grouping objects together. Now in Oracle, things are completely different. As a minimum, an Oracle instance is made up of just the processes, the allocated memory, and a parameter file called a P file or an SP file. Bizarrely, you don't need to have a database to have a working Oracle instance, and this is where it starts to get tricky. In Oracle, a database refers to all the physical files used by a whole instance, and you can only have one database in an Oracle instance. Now, if there's any Oracle DBAs listening, I'm sure they'll tell you that in Oracle 12c it is possible to have multiple databases in one instance called multi-tenant container databases, but that is beyond the scope of this talk. So we're just going to stick with the traditional way that Oracle builds a database. In Oracle, we have a concept called a table space. This is a logical container for your data files in a similar way to a SQL file group, but not always. As a minimum, Oracle database will have a system table space, a sysorgs table space, temporary table space, and an undo table space. We will also have some redo logs and a control file, all of which we'll talk about shortly. In Oracle, the expression creating a database means creating an entire database system that contains data files, control files, redo logs, and undo files, or undo table spaces. Finally, an Oracle database doesn't hold your objects, your tables, your views, your procedures, etc. For that, you need a schema. And it's a schema that holds your tables, views, procedures, functions, and the like. And the schema is linked to a table space and the physical files that the data holds. Essentially, an Oracle schema is the equivalent of a SQL Server database. But there's more to it than that. In SQL, a database not only has tables and views within it, it also has user logins. In fact, a database can have lots of users or logins, each with different permissions. In Oracle, schemas are linked to just one user account. In fact, quite often, schemas are thought of as users. Put it this way, I can create a schema called AdventureWorks, create tables and views within it, but I also can log into the Oracle database as a user called AdventureWorks. I could create another schema called John Smith, and I could give John Smith to the tables within the schema called AdventureWorks. Essentially, in Oracle, a schema is a user's personal workspace where they can create their own tables, views, procedures, and the like. That user can grant permission to other users or other schemas to view and alter their objects. As I said on the previous slide, in SQL Server, a schema is primarily used for classification whereas in Oracle, a schema is effectively a user. Are you confused? Hopefully things will come a bit clearer as we move on. Here is a different diagram. This one has come from the Microsoft website comparing SQL and Oracle. On the left we have a SQL server. We have an instance containing two databases, each database having several schemas with their own objects, such as tables. On the right is Oracle, where there is an instance but with only one database within it, and inside this database are several schemas with their own objects. Now I've confused you, let's go a bit deeper and look at the storage structure. In SQL Server, a database has a file group to store its objects, usually called the primary file group. The file group is the logical grouping for the physical files that sit on the disk. It also has a transaction log file, which is separate to the file group, and it can have more than one file group with its own set of data files. In SQL, a file group can only belong to one database. In Oracle, a schema uses a table space to hold its objects. Just like a SQL file group, an Oracle table space is a logical grouping for the physical files that sit on disk. Since a schema is effectively a user, there will be many schemas in the Oracle database. They could have their own table space and data files, or quite likely a schema will share a table space. It's also possible for a schema to put its tables in more than one table space. The big difference here is that a schema can use more than one table space for its objects, and a table space can be used by more than one schema. Finally, there is no transaction log for an Oracle schema. Transaction logging and rollback is done in a completely different way. Oracle has two separate files which are shared by all the schemas. It has a set of redo logs to hold changes made to the tables. Now these redo logs can be used for restores in the same way a transaction log is used. And we also have an undo table space. And this is used during an update, a delete or insert to capture the before image of data in case a transaction is rolled back. And these files are shared by all of the schemas. One major difference between Oracle and SQL is in transaction processing. In SQL, if you do an insert, an update, or a delete, the change is committed automatically unless you actually type in begin transaction. In Oracle, transactions are implicit. You must type in commit or rollback every time you issue an update, insert, or delete command. Otherwise, the transaction will not complete. It is very easy to leave a transaction open in Oracle because you have forgotten to commit it. So do watch out for that. Moving down one more level to the physical level, this image again is taken from the Microsoft website and provides a comparison of the storage architecture in Oracle and SQL Server. In both systems, data is held in a similar structure, just different words. So in SQL we have heaps, extents and pages. In Oracle we have segments, extents and blocks. The main point I want to show is the difference in block and page size. So in SQL Server the page size is fixed to 8K. But in Oracle the block size can be anything from 2, 4, 8, 16 or 32K. Now my previous manager, who is an Oracle DBA, loved to point out that this makes Oracle so much better than SQL because it means Oracle can be tuned to the data size and throughput. For instance, having a large block size can improve throughput when you need to read high amounts of data, such as in a data warehouse or images or something like that. When you have small data, like you're just holding integers, then a small block size can be much better performance. But the funny thing is, most Oracle DBAs will just use an 8K block size as a good all-round setting. The effort involved in testing the different block size to find the best throughput just isn't worth it. Finally, let's compare the different parts of the SQL Server and Oracle architecture. There are different names used by each, but they have similar functions. So the master and the resources database in SQL are loosely equivalent to the system and the sysorgs table space in Oracle. I've drawn them separately but you may see other diagrams that show you them interlinking between these parts. The model database is similar to the Oracle Data Dictionary, which is actually held in the system and the sysorgs table spaces. There's no equivalent to the MSDB database. We don't have a scheduler in Oracle by default, though some of the other features which are now being placed into MSDB can be found in the sysorgs table space. The SQL TempDB database is equivalent to the Oracle temporary table space. They both do the same sort of thing. User data is stored in the user databases in SQL and in user schemas in Oracle. And in SQL, each user database has its own transaction log, whereas in Oracle, it has shared redo logs and undo table spaces. Now, the startup procedure for Oracle and SQL are completely different, and this is quite important to understand. So in SQL Server, we start SQL Server with the SQL Server service. This reads from the registry the location of the master file and error file using the -d -e -l command line option, and the master database is opened. This contains the location of all the other system databases which are opened. The master file also has the location of the user databases which are opened along with the transaction log files. And now the SQL Server is ready to receive connections. Oracle naturally is a bit more involved. On Windows we have an Oracle service, oracle.exe. In Linux it works slightly differently. We have an Oracle process which is automatically started when Linux starts. But in both cases we end up in the same position. The Oracle instance starts up, but it's in an idle state. At this stage no data files have been opened and no users can connect to it. But as we'll see in the demo in a moment, the DBA can connect to this idle instance using a special system account, and using that system account we can issue the startup command. Now, during the startup process, Oracle goes through 3 stages before it's ready for user connections. We have the no mount stage. During the no mount stage, Oracle first opens and reads that initialization file that we talked about, the P file or the SP file. And this file holds information about how the database is configured. For instance, the size of all the different memory areas, the name of the database, the maximum number of processes that it's allowed. And the memory gets allocated and the background processes are started. And together, these processes and the allocated memory make up your Oracle instance. You remember that I said an Oracle instance doesn't have to have a database. The next stage is the mount stage, and here it opens and reads its control file. Now the control file is a binary file that tracks important database information such as the location of the database data files and the state they're in. In the mount stage, Oracle determines the location of the data files but doesn't actually open any of them. The last stage is the open stage. It now opens all the data files associated with the database and makes sure that all the data files are in a consistent state. Once it has opened and loaded them, the instance is now ready for user connections. When you run the startup command, you can choose how far through the stages you want to go. So you can just run startup to the no mount stage or the mount stage, and the reason for these different stages is to do with the recovery of damaged files, for restoring data, for making configuration changes which can't always be done when the database is open and running. We can set Oracle to go through all these stages to open without the need for manual intervention, so that if a Linux box or a Windows server is restarted, Oracle can automatically load and go to the open state. So now we've got Oracle running. How do we actually view our Oracle instance? Well, Oracle provides us with a number of tools out of the box. First of all, we have Sql Plus, which is a command line tool beloved by most Oracle DBAs, and this is the tool that you'll use most often with Oracle. We also have Sql Developer, which is a GUI that's a bit like SQL Server Management Studio, which gives us a graphical view of the instance and a query string so that we can run queries against our database. We also have Oracle Enterprise Manager, or OEM, or Grid. This is a web-based tool that allows DBAs to manage their instance. It allows them to create users or schemas, update storage, and do all the normal DBA tasks that you need to do on a database. It can also give you some performance stats, so it can be quite handy to see how your database is performing. Now, very popular third-party tools used by Oracle developers is Toad by Quest, and this can also be used to query a SQL Server. Now, if you're running on Linux, you'll almost certainly need a tool to connect to the Linux machine. Just about everyone uses a product called Putty, but there are other tools and emulators around if you wish to use them. Time for a demo. I've got an Oracle database running on Linux on a Hyper-V virtual machine on my laptop. The Linux server has already been started and the Oracle instance is running in an idle state. So we're going to connect to our Linux box using SSH, log into our Oracle database, start it up and run some queries against it. So here goes. Here I am on my laptop. On my desktop, I am running Hyper-V on this laptop, and I have a virtual machine running Oracle Linux called CLW SWL002 that has Oracle Enterprise already installed, and that is what we're going to connect to. So let's minimize that. I'm going to use an SSH client Putty to connect to my Linux server. I already have it listed, so let me click open, and I'm going to log in using a special account called Oracle. Now the Oracle account gets created when Oracle is installed, and this gives special permissions to the Oracle database when you use it via your SSH connection. So this is Linux. This is SSH. This is Linux's equivalent of Windows Remote Desktop Manager, but all we get is a command line prompt. There is no GUI, there is nothing useful, so you do need to know your Linux commands and your SQL commands very well to use this. But Oracle DBAs prefer this method of communicating with an Oracle database. First thing I'm going to do is check my Oracle environment. So I'm going to type in ./ora-env, and that will tell me that my current Oracle ID is ORCL12C, which is the one I want. So I'm not going to change anything. I'm just going to hit return, and it will keep the value that we need. Now I can connect to my Oracle database using Sql Plus. So I'm going to type in SQL Plus /as sysdba. Now, because I've already logged in to Linux using this special Oracle account, I don't need to supply a login name or a password. I can just say / and then as sysdba, so it's going to give me system permissions once I've logged in. And I can hit return, and that will connect me to my Oracle database. But as you can see, it's come back and said connected to an idle instance. I can run a command such as show user, and that will show that I am logged in as user sys. But if I try and run a query against one of the system views, such as $instance, then all I get back is an error message saying that Oracle is not available. So I need to start up Oracle. So let's issue the startup command. I'm not going to give it any parameters, so we're not going to stop at any particular point. It's just going to go all the way through. So it will go through the no mount stage, allocating all the memory. It will then go to the mount stage, where it will look for all the database files, and then it will go to the open state, where it will open all the data files, check their consistency, and make them available. And there we go. The Oracle database is now up and running. Remote connections could now be made to this database and users can start using it. So if I do a quick right click, I can load up the command we had before. So I could say select star from $instance. Let's have a look at that view this time. Hit return, and it hasn't done anything. It's just come back with a number 2. In Oracle, you must end every single command with a semicolon. In SQL Server, it's still option, but in Oracle it's compulsory. So Oracle is now waiting for more input because I haven't put a semicolon in. But if I add my semicolon and hit return, it will now return the data. But because we're using Sql Plus, the data is very badly formatted. It's very difficult to read. And this is one of the drawbacks of Sql Plus. Even if we try and select fewer columns from that table, so I'm just going to select those few columns there and hit return, we still don't get a very good format. Now what Oracle DBAs will do is they will put some formatting commands in so that the layout looks better. So let me paste these in here. So we're going to set the page size, the line size and the column spacing as we wish, and then when we hit return we now get a layout which makes a bit more sense. We have another system view which is very often used in Oracle. So if I hit this, the $V database view, and we can now see that our database is called Oracle 12c, created on July 2016, running in no archive log mode, and it's running on a Linux 64-bit machine. Now if we want to create a user in Oracle, it's very simple. We just issue the command create user, in this case John Smith, identified by password 123, and that will create a user called John Smith. His password will be password 123, and he will be allocated space on the user's table space. Of course we could create a user such as AdventureWorks, identified again by password 123, because users and schemas are the same thing. So the AdventureWorks user may never actually log in. It may just be used to hold data which other users or schemas will be able to access. So let's try and log in as John Smith. If I pull this over here and I run up a Sql Plus session. Now I'm just going to put in here John Smith at the name of my database. So I'm actually connecting to it using this long name here. And if I hit return, it'll ask me for the password, which of course is password 123. And it will come back and tell me that John Smith lacks the create session privilege and log on is denied. Oracle works on the least privileges method. So even though we've created a user, the user can't log in because that user could be just a schema such as AdventureWorks. So it never needs to log in. We actually have to give John Smith the ability to log in. So let me run the command back over here in my session called grant create session to John Smith. If I now come back over here and let's try that login name again. So John Smith at Oracle Canada, hit return, give him his password. And he can now log in. He can now go and view the data that he has permissions to, which obviously isn't anything at the moment. We'd have to give him permissions to the AdventureWorks schema or whichever schema he needs access to do his work. So that's Sql Plus, which is beloved by Oracle DBAs. Another tool available to us is Sql Developer, which is a graphical tool to help us manage our Oracle database. I've already started it down here, and I have some connections already available, which I've configured before. So let me click on David P at CLWL002. And here we can see all the options which are available to us in Oracle. So we've got tables and views, indexes as you would expect. We have packages and procedures and functions, triggers, all the normal stuff you would expect to see in a database. Down here it's actually called other users rather than other schemas, which is interesting because the correct name is schema. And here you'll see all the users or schemas that come built in to Oracle. There's our John Smith user, and there's our AdventureWorks schema that we built. We can also run commands in a query window. So if I go back and run that select star from $instance, I paste that in, click go, we get our results in a nice useful table where we can read it. Personally, I like using this because I'm used to Management Studio, so I like a GUI, but most Oracle DBAs much prefer using their Sql Plus, but obviously you need to know all your commands if you're going to use Sql Plus. Finally, one more tool that comes with Oracle out of the box is something called Enterprise Manager, OEM, sometimes also known as Grid. This is actually Enterprise Manager that's running on my Oracle instance that's running in the Microsoft Cloud. This is a very useful tool. This is just the Express edition, so it's only connected to my one database. You can get the Enterprise edition, which would allow you to have all of your databases listed here. From here we can create users and roles, profiles. We can manage our table spaces, our undo management, redo logs, control files, our initialization parameters on memory. Everything we need to be able to do in Oracle we can do from here in a nice useful GUI. As well as that, it gives us performance graphs on how our Oracle database is performing, so we can see queries that are running, how much CPU we're using, how many sessions, the memory usage, and data storage. And this is really, really useful. I wish there was something like this available with SQL Server out of the box. So they are the tools that we use with Oracle. Another major difference between Oracle and SQL Server is the way they manage backups. Now in SQL Server, the backup process copies the contents of the database files or the transaction log to a backup file, and this can be done while SQL is running. In Oracle, there is no concept of a backup file like we have in SQL Server. A backup is simply a physical copy to another location of the files that make up the database. Now, Oracle, there are two types of backup. Firstly, there is the cold or offline backup. Now, the Oracle literature says that to ensure transactional consistency of your backup, the database must be shut down, turned off, and then you simply copy all the files to another location, and this is known as a cold backup. Now let me say that again. To do a full transactionally consistent backup of the data files of an Oracle database, you shut it down and then you simply copy all the files to another location. Now some Oracle DBAs can get a bit upset when I say this. They will say that this is not strictly true, but I love to wind them up by pointing to the official Oracle documentation that states this. And to restore an Oracle database, you shut it down and copy the files back. This is obviously not very good for a production 24/7 system, and it's not quite as bad as it seems. It's much more likely that you'll back up an Oracle database while it is running using what is called a hot or an online backup. The database has to be running in a special configuration called archive log mode, which is equivalent to the SQL full recovery mode. And we issue a special command called alter database begin backup. Now Oracle backs up the contents of the redo logs, and the redo logs are the ones that hold the changes to a record that we could use for a restore, and these get copied to a special file called archive logs. Now the data files can now be manually copied to a different location in the same way as you would with the cold backup, but during that file copy the data files may still be being written to. So hot backup is also known as an inconsistent backup because the data files could be in an inconsistent state. Once the data files have been copied, the redo log and the archive log files must be copied as well, and the backed up data files and those redo and archive logs generated during the backup window constitute your consistent database backup. To restore, we still have to shut down the database and copy the files back. We can then start Oracle in the mount stage so the transactions can be replayed from our archive logs. And this is why we have those different startup levels that we saw earlier. Now Oracle has a separate process called the Recovery Manager or RMAN that can hold backup configurations and can run all our backups. It can run hot and cold backups, full backups, as well as incremental, differential and cumulative backups. With RMAN you can configure the location, compression, encryption, retention policy, the files to be backed up, and even verify the files. It will keep a history of your backups and you can use it to do all your restores. And this is the tool that Oracle DBAs will use to manage all their backups, and it takes away all the uncertainty and complication around doing hot and cold backups. But it doesn't have a scheduler. You'll have to use a Linux scheduling program to actually run your RMAN process for you. As you all know, in Windows you connect to an instance over your network using TCP/IP and DNS. If the SQL instance isn't the default instance, then the browser service must be running on the server, and this directs connections to the named instance. Now, Oracle has its own proprietary protocol called TNS, or Transparent Network Substrate, which sits on top of TCP/IP or whichever network protocol is being used. On the client and environment variable TNS_admin points to a folder that contains a file called tnsnames.ora, and this is a text file which lists the Oracle instances with the server name, the port number, and the instance name, and your Oracle application will use this file to find and connect to the Oracle instance. So in this example, this is a very simple example. I will connect to my Oracle database, which I am calling my Oracle database. It's using TCP/IP. It's actually sitting on a server called Server 1. I'm going to connect via port 1521. The actual Oracle database on that server is running as a service called Aura 12c. Now, on the server where Oracle is running, there is a service called the listener service. And this must be running, and it listens for requests and directs them to the correct Oracle instance. The listener has a similar file to tnsnames.ora to know how to deal with incoming connections. There is also another file called sqlnet.ora on both client and server, and this will hold configuration information such as tracing options and encryption. If you don't have a tnsnames file, it's still possible to connect to an instance by putting the connection string on one line, such as something like this. There are other ways to connect to an Oracle instance, but this is definitely the most common way to do it. Is it possible to connect to Oracle using PowerShell? Yes, you can. You will need to install the Oracle Data Access components, which you can download from oracle.com. Specify the location of the managed data access.dll, and then you can connect to it with a similar PowerShell query to what you see on the screen there. So just to recap, in SQL Server, an instance or a server is equivalent to an Oracle database. A SQL Server database is equivalent to an Oracle schema. SQL Server schema doesn't have any equivalent in Oracle. A file group maps to a table space. A SQL login or a user maps to an Oracle schema or a user. Permissions are called privileges. Index views are called materialized views. The equivalent to T-SQL in Oracle is called PL/SQL. Error logs are known as alert logs. Transaction logs are known as redo logs. And your execution plans are known as explain plans. So I hope that has given you a good introduction to Oracle, and that you'll be able to converse with your Oracle DBAs more easily. If you wish to contact me, my details are on the screen. If you would like to try and build your own Oracle instance on Linux 7 on Hyper-V, I have written a white paper which is available on gethanellis.com. It will take you step by step building your Hyper-V machine, installing Linux, installing Oracle, and connecting to it from your laptop. I have further videos on my YouTube channel which you can listen to. If you have enjoyed this or found it useful, please do write and tell me, or put a comment on my YouTube channel. I would be most appreciated. Thank you very much for listening, and see you next time.